So I forgot to mention this in the last video, but when you're doing the homework, I think the last problem, you're going to see a wacky circuit component that looks something like this, I'm pretty sure. And all this is a generator. It's pretty much the same thing as a battery. It's just the electromotive force is, I think in the book, is 100 sine of 6ct. So it's pretty much the same thing. You just do negative times this electromotive force for your differential equation. The only thing that's different is that it's not DC, it's AC power. But pretty much, if you see like wacky symbols like that, as long as you can like figure out the units next to it, then you can plug into the differential equation and you'll be fine. So anyways, after looking at a couple of real world applications, we're going to take a more theoretical look at first order systems of differential equations and really why you would want to make a system of differential equations out of a higher order differential equation, besides, I don't know, like wanting to torture yourself or something. So how we're going to do this is we're going to consider a system of a single differential equation. Let's say x differentiated n times is going to be equal to a function of time, x, and all of its derivatives up until x differentiated n minus 1 times. And so how we're going to convert this into a system of differential equations is by reassigning new variables for all these different derivatives. So instead of having the same interrelated variable, we're going to have completely new variables for all of these. And then you're going to see how they're related through equations instead of just differentiation. So let's set x1 to be equal to x, and then let's also set x2 to be equal to x prime, x3 equals x double prime, so on and so forth until we get to x sub n equals x differentiated n minus 1 times. And so you can see in this system that if you differentiate this equation, you're going to get the derivative of x equals x1 prime, and then you can see, the derivative of x also shows up in this equation, equal to x2. So then x2 equals x1 prime, and so on and so forth, like x3 equals x2 prime. And so what we're going to be able to do is essentially convert this list of variable reassignments into a system where we have x1 prime equals x2, x2 prime equals x3, so on and so forth until we get to x prime of n minus 1 equals x sub n. And then this is the tricky part. X sub n prime, this is going to be equal to x differentiated n times up here, is going to be equal to the entire function. And then pretty much what we're going to do is do all of these substitutions into this function. So instead of having x, we're going to have x1. Instead of x prime, we're going to have x2, so on and so forth, until we hit x sub n. And this is the general process for how we're going to break up higher order differential equations into systems of first order differential equations.